connected to the microcontroller for communication. Okay, so there are a lot of display devices, like you have LED, light emitting diode can also be used for display devices, and you have 7-segment where you could also communicate with 7-segment. Okay, and you also have the LCD and like LCD display and LED display. Okay, so LCD stands for liquid crystal display, where it uses the like light modulating properties for display. So there are different types of LCDs, like you have 16x2 LCD where you will be having 2 rows and 16 characters. Okay, these are all 4 rows and 16 characters. Okay, you also have like display TFT display, which also comes under this LCD category. TFT display with LED TFT display as well as the LCD TFT display. Okay, so this is the pin details of the LCD display. You could get the datasheet very easily. VSS stands for ground and VCC for 5 volt. This is V for contrast control. Okay, and RS for register select. Register select, because in LCD there are 2 modes. One is the command mode, the other is the data mode. Okay, the character mode. If you send RS equal to 0, if register select is 0, then it is command mode. If register select is 1, then it is the data mode. Okay. So the read write is 0 for write and 1 for read. So mostly we will be using only the write operations on an LCD. Very rare case for read operations on an LCD. So enable, you have to send a pulse, slow to high pulse for 3 milliseconds. Okay, so that will enable. And D0 to D7, like data, this is, the LCD can operate on both modes, both the 4-bit mode. If you want to use 4-bit mode, it can be used for 4-bit mode on the 8-bit mode. So today class is about 8-bit mode. I'm going to use 8-bit mode. 4-bit mode, you could also use 4-bit mode. Okay. So this is one example of connecting 4-bit mode. Like you have to connect from D4 to D7 to 4, only 4 pins. So you'll be separating 4 bits, like lower nipple and upper nipple, and you will be sending the data. Okay, for display. So D0 to D7, and this is how we have to display the character of the LCD, like lower nipple and the upper nipple. Okay, so here is the steps. Step 1 is to initialize the LCD. Okay, so you have to send 02 command, which initializes the LCD in 4-bit mode, and 28 command, which configures LCD in 2-line 4-bit mode. Okay, 28 and 38, you have to check the data sheets. So display on command is 0E and 0C, and 06 command is to increment cursor. Okay, so you could get the command data sheets if you just Google for command data sheets of LCD. Like you'll get the command, like what are the list of commands are available on LCD. So let's go for the program today. I just opened the STM32Q by DE. Okay, so I have a folder called in C:, like I have a folder called day 26 demo. Okay, so I have already copied the header files here, which the previous program, in the yesterday program, we have gone through like how to download this, how to download the software and how to include the header files. So I just copy this path. Okay. First configure the board. I'll go slow and I'll explain you step by step. Okay, so we'll be using 2 ports here. One is port C, the other is port B. Okay, so we have go for file, go for new STM32 project. You have to choose the board, and like first you have to include the header files. So for data pins, I have used ports from PC0 to PC7, okay, and for the RS, like I have used port B5 and B6 and B7 for register select, and for read write I use B6, and EN I use B7. Okay. So once, okay, so choose a board selector as click board selector, choose the board F411RE, okay, choose this, click next, and this is example. I rename this as LCD, click empty, click finish. Okay, first I will increase the font size, go for Windows, preferences, and general, click general, appearance, okay, colors and fonts, C++ editor. Okay. I choose as 18, okay, apply and close. Click source file, click main.c. So I remove all this code. Okay. So let's start with, let us include the header file, hash include STM32, okay, F411 STM32 F4xx.h. Okay. Now try to build this file, right click, build the project, it will show the error. Okay. So now you have to link this file, properties, you have to include the header files, settings, you go for C++ build settings. In this, you go for MCU GCC compiler, go for include paths. Okay, click this one, file system, create, copy this in STM, you go for STM32, sorry, it's day 26, okay, day 26 demo. Include, I just include this folder, okay. So we have one more folder, file system, device ST include, okay. So I have included this two folders, apply and close. Okay. So we need to go for open declaration. Okay, you need to add the symbol also. So symbol you can get it from here. You copy this symbol, right click, go for properties, and go for preprocessor. You need to click this symbol, add. Okay, apply and apply close. Okay, right click, build the project, check for error. Okay, so it's perfect. Okay, so we have included the header files. Now let us start writing the program. Okay, so first I'm going to use PC like PC0 to port C0 pin to port C7 for D0, sorry, D0 to D7. Okay, D0 to D7 in LCD. Okay, and I'm going to use PB5 for PC7 for register select. Okay, PB6 for RW. Okay, and PB7 for EN. Okay, for enable. So these are the connections which I'm going to make it on the LCD. Okay, so if you want to check the if you want to see the pins, like it's here. PC0 and PC1 is here, PC2 and PC3 is here, okay. PC4 is here, and PC5, PC6 and PC7 is here, okay. Similarly for PB5, PB6 and PB7, PB5 is here, PB7 is here, okay, and PB6 is here and PB5 is here. Okay, so we are going to use this pins. So I have used a custom add-on card for my LCD, like I'll show you that. Okay, so let's start the program. Okay, so first you define the GPIO. Okay, so hash, create the symbolic name for hash define okay. Hash define RS is 20, okay, for port B5, okay, because we are using B5, okay, so it's 20, and for read write it is read write is 40. If you convert this to, okay, hex, choose hex 20 and check for the binary, okay, 0 1 0 1 2 3 4 5, okay, it's P5, okay, it's P5. If you check the binary value of this, it's 0010, okay, yes. If you check the binary value of this 010, right, okay, hash define, so create the symbolic name for en is 7, it is 80, okay, choose 80, okay. So we have created the symbolic name. Now let us initialize the GPIO. Okay, let us initialize the GPIO first. So just create a function for GPIO. So void of GPIO underscore init. Okay, so void underscore GPIO underscore init. So here you have to enable the bus for RCC, and you have to enable the bus for port C as well as port B. You have to enable okay. So the value to enable both the ports, like PB and P6 is 06. Okay, 8421 is 06. Okay, to enable port B and port C is 06. Now, like, we have to set both the modes, GPIO B and GPIO C, mode register. Okay, as both the modes are output, have to set both the modes, both the mode register as output. 0x. Okay, you have to give the value for this. So you have to calculate this value from the data sheets, which we have seen in the previous class. So GPIO-C also you have to set the mode register as okay for because here like GPIO-C totally 8 bits. Okay, so to configure that as an output mode, like output mode is you have to set 01. You have to set you have to refer the data sheet to set 0101. So if you check for like the binary value 0101, okay, is 55. Okay, so it's 5. So you have to enable for all or for all the you will get 2 bits for single bits. Okay, so for single pin, so 55 you will get the value 5555. Okay, so this is to set the value on the output mode. Okay, so let me open the data sheet and I'll just explain once. So these are the port mode register. So for output mode, you have to choose 01. Okay. So for P0, this is for mode or 0. For 0th pin, first pin, second pin, third pin, fourth, fifth, sixth, and 7th. So you have to set 01, 01, 01, 01, 01. Okay. So you'll get 5 for this, 5 for this, 5 for this, and 5 for this. Okay, so this is for set for GPIO port bit set register and as well as the reset register. If you want to set the bit to okay, so we are going to enable and set EN and RWL0. Okay, so let me open the code. So you have to GPIO B, just go for bit set okay, 0x000C. This is to set EN pin and RW low. Okay, so that's all about GPIO unit. Now let's go for the LCD unit. Okay, first we will LCD command. We will write the LCD command. Okay, first in LCD when you for selecting command RS, you have to select 0. Okay, if and RS is 0 and RW is also 0. Okay, so you have to give RS as 0, RW is also 0. So for that you have to GPIO-B, RS is connected to GPIO-B, RS and RW. Okay, and BSRR for setting RS. Okay, so this will give you the R with the RW. So shift for 16. So this will clear the bit. Okay, GPIO-C, the ODR, like the ODR is for output data register, is the command. Okay, now you have to GPIO, have to enable a short pulse. This is for enable EN. Okay, just give a small delay, so delay of 15 milliseconds. Okay, so we need to write the function for this. So int of 5. So I just put a simple loop for delay greater than 0, delay minus. Okay, I just put a simple delay loop. So this value you have to calculate by using the crystal from the clock. Okay, so we have configured the delay loop. So delay milliseconds, and again you have to load this one for okay. So this will give a short from it will go from low to high. Initially it will be low, so it will go for high and it will again become low. Okay, so this is the LCD command, and let's go for the LCD data. Okay, I'll just copy this. Okay, let's rename this as data. So data, for sending data, first you need to give RS should be 1. Okay, and RS should be 1 and RW equals 0. So GPIO-B, you have to BSRR, okay, equals RS. This is for 1. GPIO-B, again you set BSRR equals RW, okay, 16. This is to clear, and GPIO-C, ODR, output data register. You have to move this output data register to data. Again, you have to give a pulse of this enable, and you have to give this pulse. Okay, a short pulse. So you make it as 30 here, make it as 30. This also 30. Okay, a simple short pulse. So this is clear EN. Okay. So we have written a code for data. Let's return the code for LCD initialization. Okay. So write void LCD underscore init of void, open the bracket. Okay. So first thing on the LCD initialization is GPIO init. You call this function. Call this function. You have to initialize GPIO init. Okay, else it won't work. And then you have to call the command, LCD command. You have to send the command. To set the LCD command, you have to check the value of this command 0x28. Some it will be 0x28, some it will be 38. Okay, this is to set 8-bit data mode. Okay, 8-bit data mode. So just give a delay of 15 milliseconds and copy this command. Next is 0C. Okay, and 0.6 for move the cursor right. Okay, this is for clear screen and turn display. 01 for clear screen and 80 for turn display. Move cursor home. Okay, and this is to turn display. So these are all the commands. Turn display. Okay, so we have given this LCD command delay. Okay, so I'm just going to declare a message on the top. So just I'm going to unsigned char of unsigned char message hello world. Okay, I just type hello world. Okay, so this is the message. So unsigned char of I equals 0. Put on the top. I just put a simple while loop, while of message of I not equals next line. Okay, 0. So LCD underscore data. Okay, message of I. This is I plus plus. Okay, I just give a simple delay. Okay, so let me check now. So we have to declare all the prototype on the top. Like I just copy this, paste it here. Okay, copy all the function prototype. Okay. So we have written the function for LCD initialization data on command. May cross check whether we have any error. We have 3 errors as of now. Okay, build this project. It's build. So now let me write the main program to display. So you have to call this LCD init on the main program. Right click, build the project. Okay. Right click, run as STM32 Cortex application. Okay. So it should work now. Okay, the program is downloaded to the controller. Okay, but I'm not getting any display. Let me check the program once. So first we'll start with GPIO init. GPIO init is HP1ENR is 6 and motor register GPIO B set ENN or RW or low. Okay, B is RR is 00C. And LCD command is 16 ODR equal to command EN, okay, 30. Okay. So LCD data, like LCD data is RS 16 data EN 30. Okay. We have to write this function cut. We have to write this function. It's not at LCD data. It should be on LCD init actually. It should be here actually. It's not on data. Cut. Okay. Let me check now. It should work now. So once I got the display, like I'll show you the output on the screen. Still we have some problems, like it's not displayed. We change some delays. So there is a slight change in the code, like you have to change the delay is 0. Okay, so I'll just remove this delay. And one more mistake we have made here is 06. It should be 06. Okay. Now right click, build the project. And let me download this. Okay, so it is displayed now. Let me show the output. Okay, so this is the board which is connected, like it is connected to this port C. I have connected port C and port B. Okay, so this is the output. Let us check now. Let us check for just build this project. Okay. Okay, so we got the output. I'll explain the code one more time and we'll close the session. So I have declared the header files. Okay, I have declared the header files for STM32F411H, and I have give the symbolic name for RS, RW, and EN. So 20, this is for 5th pin. Okay, because we have connected this to 5th pin, 6th pin, and this is the 7th pin. Okay, and like we have initialized the GPIO port B and port C. It's set as an output mode, and we are setting EN and RW as low initially, because RW will be always low because we are going to write, so we're not going to use read. So order and EN is initially every time it will be low, and whenever you want to make it high, and then again you want to make it low. Okay, so LCD command, like this is for setting RS0 and RW0, and pass the command here and enable. You have to enable it high and again back again to low. So data is also same thing. Only thing is you will be giving RS is 1. RS you have to give 1, and for read rate, like enable pin, you have to make high and you have to make low. So we have made this mistake here, like LCD. So these are the commands which you have to send. And message, it takes the message and it sends it pass to the function called LCD data, where it prints the data to the corresponding cursor position. Okay, so delay is used to generate the delay function is used to generate delay. So this value you have to calculate for a 16, like we are using a 16 megahertz crystal. So it is calculated for the 16 megahertz crystal for giving the correct delay, approximate delay. Okay, so thank you so much for your time. See you in the next